Thank you so much for taking time and coming out here. Right? This is our 7th meetup. I did not even realize that we have grown such from a very small group of, I think we were around about 20-25ish when we did our first meetup. But I'm seeing a lot more new faces, lot more folks coming into the meetups. Right? Thank you so much. Again, thanks to Jay and the entire health catalyst team for giving us the opportunity for doing the event here. We might be collaborating with Jay and health catalyst team a lot more than we are going to be doing, right? So they were part of our PG Day Hyderabad also, right? For all the folks who had some super tasty Hyderabad food on the PG Day evening, right? Thanks to these folks, right? And then the drinks were on them. Right, so we've got we will be introducing a new segment this time around, right? We will do a round table, and then with round table, we'll also play the bingo game, right? I'll let you guys know what is a bingo game. If you already know, do not reveal that. So keep that secret with you guys, so you can win the prizes for yourself, right? So we have got a new first-time speaker with us, Zubair. He's from Mattermost. He's going to be talking about Explain Analyze, right? Who does not want to know about Explain Analyze and the intricacies of Explain Analyze, right? And we have our organizing member, Rajesh, talking about logical replication. And Abbas also going to be talking about how do we convert a physical replica into a logical replica, right? And then we look at the round table and see how things go by. And at the end, Brahmani wanted to discuss with us what Postgres Women India are going through, right? What are some of the initiatives they are running, right? What is the help that the team at PWI needs from all of us, right? And these are our handles, social handles. Please do follow, spread the word, right? We would like to do our meetups frequently as possible. Now we are sticking to a cadence of once in 2 months. If we have enough traction, if we have enough speakers available, if we've got enough logistic arrangements available for us, we are ready to do it 45 days or trim down to 30 days too, right? And again, we have launched our website, pghyde.in. We will be leveraging that website for all the data distribution, the slides that are being delivered by our speakers here, and the earlier meetups that we have done, right? And obviously the PG Day, the entire PG Day slides, YouTube video links, everything is available on pghyde.in, right? To give your feedback and let's see how well we can grow, and then see when we can do the next PG Day, and when we can do our next meetup, and then we'll revisit the frequency of our meetups and so on and so forth, right? Any questions, comments? Myself, Rajesh, and Abbas are here, right? Hit us back with your questions, comments, thoughts. We'll be happy to incorporate anything small, big, good, bad, ugly feedback, right? Anything is welcome. And then we have Zubair. Zubair is our first time speaker. You're from Mattermost. I'll let you do your introduction while I'm copying your presentation.
Hello everyone, my name is Zubair. I'm from Mattermost, and this is my first conference apart from JavaScript. Before that, I've been doing a few conferences on React and JavaScript in general, and I wanted to switch up a little bit and start with something new. So my talk is going to so before this, I wanted to have a series of talks so that we can get into depth of explain, analyze, and what all other parameters we have with options, with buffers and all that. So today we are going to look at part 1 of the series, that is understanding, explain with analyze. And then again, if Hari allows me, then yeah, we can come back.
We'll be more than happy to have as many sessions as possible from you, man.
So,
Yeah, just a second.
A little bit about Mattermost. We are an open source collaboration platform for enterprises and communities. So till some time we were called as open source Slack. So we have moved away from that, and now we are focusing more on enterprises, on federal customers, and communities in general. So our Mattermost again uses Postgres as the database. We also have MySQL, but we are deprecating that and trying to move all our customers to Postgres. So let's start with the syntax. Explain again. If you put your query statement behind explain, that is how you do. If you want to have a parameter, then you have explain, analyze, and then your query. If you want to have more than one option, or more than one parameter, that is how you do. Like buffers, we have settings, we have verbose, all the other options, and that is how you can pass on to the explain function. So we are going to use this table, just a very simple table with users, usernames, and all that, just to keep things simple. But you might also take a look at the indices which we have for which fields we have, right? Just so it'll be useful when we go forward with. Okay, let's execute a very simple statement: select star from all users, and let's add explain behind it, right? So we get this pretty simple one-liner. It says sequential scan on users. We have some numbers over there, some with like rows and widths and all that. So let's try to understand what all these numbers means, right? So the first one, what you see is now this is just explain. This is without analysis, without analyze. So that means the planner will not actually execute your statement, your query. It will not actually execute it. So but it is going to show us the plan, how is going to execute it. So it's not yet executed, right? So this query planner first sees, okay, which scan plan should I use, right? There are multiple scan plans. We'll go that in later, and we have the scan name over there, and then on what on what table, and then in the parentheses which you see, you have something called cost, rows, and widths, right? So costs again, the first option over there is the startup cost. Okay, again that unit is not time, it's a unitless value, which we're going to see what exactly those values are. And then we have something called rows. Now again, all of this inside the parentheses are all estimates. They are not exactly what the statement will return. Okay, and then we also have what is the width of the rows of each one of them. Again, approximate, not exactly what you're going to get when you actually run this query. Okay. So yeah, I was talking about the scan previously. So we also have, if you saw an earlier slide, the username was one of the indices. So that's why when I actually ran on username, select username, the scan plan was changed. You see, the scan plan previously was a sequential scan, but now because we already have the index, it changed to index only scan. Right. We have other scans as well. We have bitmap index scan, which is in between of sequential scan and index scan. Again, there are various scans as well. So let's go a bit deeper about what the numbers are, which we saw over here, right? The cost and the rows and all that. So see, as I mentioned before, these units, the cost units they don't have a unit. So you can't just say that is microsecond or millisecond. They are not like that. But if they don't have a unit, how do you compare? How do you see the value? You cannot just say I have 2 units of my cost. So the only way we can actually use this is by comparison. If we have 2 queries, you want to see which one is performant, you run both queries and see which of the two of them have higher cost, right? That is how you use this units, not by themselves, but by comparison. So obviously, all the scans have their own way of computing the cost, like the sequential scan have their own formula, or how the Postgres handles those costs. Now this one particular formula is for the sequential scan, right? So we have some numbers called seg page cost, CPU tuple cost, which Postgres have. Now these variables are these are variables which the user can actually set. Okay, so how do you, and where are these variables defined? They are defined in the system catalog, right? You have system catalog like PG class or PG stat where they are actually defined. So to just get those values, you can just query it from the PG class catalog by giving the table name, right? Now the formula also states that it's the disk page read into the seg page cost, which is usually defaulted to value of 1.0. And you can change this value, but yeah, by default the Postgres have that value as 1.0. Now this is very important variable, because all the other variables we have CPU tuple cost and all the other list of variables are referenced with this first variable. So now I need to see what was the disk, what are the disk pages which were used by my table. So I got that as 15, as you can see over here, the rel pages over here. And then I also wanted to see how many approximate rows, which is nothing but rel tuples value. And if you see, we get the cost, that is 15.6, which is exactly what we saw over here as well, like 15.6. Now, do we have to do that for each analysis? The answer is you might not have to, because what you're basically doing here is comparing the two costs between two queries, right? That's the reason it's good to understand how these are derived, but yeah, the ultimate goal of these two is to compare two queries. Now we also have the number of rows which we had like before, like what is the, yeah, there's and again, I've said that these are estimated rows count, but they are not exactly the rows which are present in your table. Now there is a good interesting use case for this. For example, you have you have a client which does not exactly need the accurate value of your rows. Like it could be a social media app, right, where you are calculating number of likes. Now usually the number of likes and all that are usually in 12.5K. The exact number is not really, does not really matter after a certain amount of point. So that's the reason, that's the use case of this. So you can actually just, instead of looking at the whole table and getting the count off, you can just write this statement and just get the estimate rows of it, which is one of the use case for this rows which I've seen. Now the width also is the number of bytes, average bytes of each row, and again, even that is inside the catalog called PG stats, and the query planner will go to that catalog to get the estimates of this. Now let's add a little bit more to this query. Let's add order by, right? Now when we add order by, now we have moved away from a single statement to like a three-liner statement, right? So the first thing that you have to do is start from the bottom. That is how you read these plans. You have to start from the bottom and then move away, then go level up. For example, again, you see the arrow over there, that is where you started. And again, it says the same thing, sequential scan on users. Then there is sort by which key. And then sort happened, and again, as I mentioned, sort also has a cost to it, right? And this is how you have to read a complex query plan, right? Now let's add analyze to this. Let's see what happens. Like, what do we get from this, right? Now, analyze, I've mentioned this before, is one of the parameters of explain. And now, now things are starting to grow a little bit, right? So first thing is now you see, not only we have estimate, we also have actual cost. So that means that when you add a parameter analyze, the query will actually execute. So you have to be very careful if you have in the query, if you have deletion or updation and all that. You have to be very careful because this actually executes the SQL query. Now, there are other things as well over here. We have the planning time, which the query planner took to see how to execute this one, and how much execute time was taken. We have that in milliseconds. Now, in the first row, I mean the bottommost row, we have actual time. This is the actual time the node of the GraphQL took to scan the users table. And again, these two values are the upper limit and the lower limit of your actual time taken to execute. Now it goes up, and we have sorting as well. So what kind of sort is this? It's a quick sort, and the memory it took was about 91 kilobyte. Now this quick sort, if you see, it was done in memory. Sometimes you can also have your SQL queries run on disk. That is one of the things that you can actually improve. Like how do I make it not run on the disk and run on the memory? And then we have sort by key. Again, the sort also runs. It also have the actual time about, and then how many loops. There's another additional thing we had was loops. So to execute this, how many times the node has to be looped together. So this is again one of the watch out things that you have to understand, how many loops is going to take, because the average value over here is per loop. It's not, if it is 1, that means, if it is 2, that means your average time is for 1 loop, not 2 loops. Okay. Something to watch out for. Okay, just like as I mentioned before, that analyze actually executes it. So be careful with when you have insert or update and all that. But again, explain cannot be used on all your queries. It only supports a subset of the queries. For example, if it is select, insert, update, delete, and there's also, I think, create table and all that. But yeah, but not all are supported when you're doing explain. So you need to be careful, like if it has this, then explain cannot be used. And yeah, there is one thing that you might notice also when you run the explain analysis is first time you get a different value, and that is because the cache has not been created yet. So it's a good idea to just execute the explain like a couple of times before actually understanding the result. And one of the things also to keep in mind is this is the database time only. It's not. It does not include I/O times. It does not include your client TCP connection, all that. It's just purely database. How much time it took to get those values? That's it. It's a pure query time. So sometimes might also happen that when you're actually seeing an improved speeds in your application, but when you actually run the explain, you see the numbers are a bit higher. So that usually happens because explain has its own overhead. So that is being included. So be wary of the observer effect is what I'm saying. So how do you plan? Like okay, explain exists and these are my options. Like how do you plan this? So let's first thing is get a realistic database. Now in Mattermost, because we are not cloud. I mean we have very few cloud customers, but most of the customers are in premises. So we don't actually have access to their database and all that. So what we do use is we try to replicate approximately how the database of our customers are. So it's usually like we approach the customers, ask them, okay, how many rows do you have in your post table or user table, how and all that. So we get that data, then we try to replicate it on our system to understand the queries. Now, number of rows is important. As you can see, the number of rows, the scan type which the explain uses depends on the number of rows. If it is if the scan type is less, then sequential scan is pretty fast. And even if you have an index table and the scan and your rows are very large, the planner might drop actually not using index. It might use a combination of sequential, combination of bitmap and index. So number of rows are important. So one of the key, you have to not what exactly the rows contains, right? Because you are using explain, so it doesn't matter what contains it is, but yeah, keep a watch out for number of rows. And the second step is the more data the better. So you have, as I mentioned in the start, there are other parameters as well, like buffers, verbose, like if you want to have a verbose setting, and there are settings as well. So all these things are there. Make use of those parameters to get as much as data as possible. Now you see over here, when we added the verbose setting, it also showed us what is the output ID, what is the column ID which we have, and what is the buffer. When you added the buffers option, it's also shared how many buffers we had, how many of them were shared hits. So all this data actually helps you plan, helps you optimize your SQL query. There is also there is also an option of including the I/O times as well. So it's off by default in Postgres. Only your database admin can switch that on. So it's useful to just switch that on so that I/O times are also included in your analysis. So once you have the data, once you ran the query, then always start from the bottom and move your way from up. So now I've also mentioned that the stats also include average of the loops, so be careful of that. See how many nestings are being and when I mentioned just read from the bottom start, that means that first concentrate on the bottommost query, then move your way up. So first identify which are the most expensive parts, where is my where is the query taking a lot of time, spending a lot of time, see that, and then when you actually identify all this, and then you start optimizing for performance and speed. Usually what happens is we directly move to step 4, and then we try to find the problems in it. So yeah. So now let's take a look at this. So you see when I ran this one, the actual time was about 0.7 seconds, but my sort was double of that, right? So then over here again you have to ask the question, is a sort even needed? Because sort is as much as double costly operation over here. Do we actually need sort? And sometimes what happens is, as I mentioned, if does the sort happen on disk or it's memory? Currently it's happening in memory, so it's relatively fine. So if you're used to reading this, I mean it's good, but if you want to have a UI to actually read this file, there are other tools as well. Like pgadmin has an inbuilt tool to see the explain, and there is a tool called pgmustard. It's paid, but I mean if you have difficulty understanding all these values and all, these clients and your clients make the work a little bit easier on you. And with that, thank you so much.
Couple of questions from my side. You can just get your PPT up and running. We'll go back now. If folks want to ask any questions on your PPT, they can ask.
Sure.
Go ahead and open that. So while we are using extensions, right? So we have seen a few extensions that are available that can enhance your explain analyze. What do you suggest? Any specific extensions you have worked?
I use pgadmin at work as well. I find it to be easier, and but yeah, the UI wise, it's a bit lacking than what you see over here. This one. So again, it depends on choice. Like few of my colleagues, they don't want to see the UI. They just see the, oh, this is what it is, and yeah. So I think it's a matter of preference, is what I would say.
I have a question.
What you do is repeat the question.
Yeah.
Right. Repeat the question so that it records on the mic.
Sure.
Right. And then start giving your answer.
Okay. Right.
No need.
I've done this sort techniques, and there is a, if you run a multiple joins in the query, so there is a group aggregate and hash.
Yes.
Right? So can you explain on that?
So the question he asked was, if we have not only sort, if we have join in tables, for example, how do you have the queries for that? I don't have the slides for it, but you feel free to check them out, how those looks like. And yeah, one thing you have to, there was one thing you have to understand is take a look at the loops column as well, like, and what are the number of rows which are returned. If you are because if you have the rows which you ran from the query being a lot more than the estimated rows, that means there is some type of caching happening, because or your database is not being updated when you actually. What happens is, these are when we run the explain one, it does not actually, because the query is not executed yet. So it goes to the system catalog of the table, and then from there it gets the row value, right? So one of the things that you can actually watch out for is if your actual number of rows returned by the query is very much higher than the estimated rows here. So you can take a look at that one as well.
Another important point, I keep looking at these explain classes. Whenever we have more number of loops, it says that the amount of operational cycles, right? The amount of operational cycles that query node is taking for us to execute, right? That's the number of loops you would want to make it as less as possible.
Yes, exactly.
Look at workman, or look at what exactly is that exact scan node trying to perform.
Yes.
Probably those are some of the areas where you would look at, hey, how many operational cycles am I doing for that specific node?
Yes, and just add to the point, we usually think, oh, you know what, the scan type was index, so that means the query must be performant, right? But that's not always the case. The index scans for like very large number of rows are sometimes not exactly performant. So just by judging, okay, I got the index scan part, okay, that means the query is performant. It's not always the case. So.
Any other questions?
You said that the explain plan totally depends on number of rows. It doesn't matter what data is there. So suppose we are having two tables, which one is having a table which data type is like taking maybe 1 GB data in one column or something, and one table is having data actually it's very small kind of. So both the explain plan cost will be same or different? It should depend, right?
Yeah, she mentioned that if I've said that the number of rows are dependent on the explain output. So yes, that is correct. If you have the single row in both of the tables, right? The only explain will probably return the same cost for this, because what explain is doing is trying to understand which is the best part to execute this particular query. It's not actually looking in to the database to how many bytes particular column or particular row has it. So I'm thinking both the cost should be the same, but the average width might be different because you have more bytes in one of the table than the other one. So
Then how it is making difference? So explain analyze will be different or explain?
Explain analyze will be different. The explain will probably both be the same for both of them.
I will be testing that.
Yeah.
Fine. To add to that, what explain versus the explain analysis, explain looks at the PG catalog tables only. What optimizer is fed with all that metadata information. Explain analysis going ahead and executing the SQL query and then grabbing all of those SQL nodes and giving you the exact information. That's why you see a difference between explain and explain analyze. Some of the metadata information you see, right? When you see bit, right? In case of bit, you will see the loops, the operational cycles.
For vector databases, does it change? So if we are using a PG vector.
Awesome question.
I have not tried. Yeah, I am not sure. So if anyone else can answer that.
Yeah, this vector database generally stores the vector data in toast, process toast. So that is outside the main table, the toast information. So like he said, the planner has some deficiencies here and there. Currently, Postgres is not considering the toast information. So there is discussion happening in the Postgres community about how to improve that. Yeah. So Postgres is not a work completely done. There are a lot of areas to improve.
Thank you so much.
Anybody want to chime in? You guys do a lot of.
Just want to add to earlier Hari's comment. If you go back to the slide where you are showing the explain analyze, right?
This one?
Explain analyze.
Oh, okay, sorry. This one? Yeah.
So the fundamental thing, what you should be really looking at when you say explain analyze, and it's very easy to really identify what the problem area and quick win is to see the difference of number of rows between the estimated and the actual. If the difference is huge, the immediate solution is something that it is not analyzed actually. You need to really gather the stats of the table, and the moment you really gather the stats, you will see the difference as less as possible. So the other way to look at around here is if you see the huge difference between the actual rows versus the estimated rows, means your statistics is very stale.
Yes.
Yeah. So immediately when you look at the explain analyze, look at for this thing and then take immediate action. That's a quick thing everybody should be doing it, as I said. I mean, of course the other elements are there, but this is the quick win, I would say.
Thank you so much.
I have one question. So this table has an index on the username.
Yes.
And when you are doing your order by username, why is the index not?
Because we are selecting, we have a select star. We are returning back the complete table.
So
if it was, oh sorry. Yeah.
By answering that, so that it records on the.
Yeah, sure. The question here was, I have mentioned before that username has an index on it, and your question was why that instead of doing index algorithm, it's actually doing sequential algorithm. If this one was select username from users, it would have used index only algorithm, but because we are retaining the complete table, that's the reason it's doing sequential scan.
There is no where clause.
Which one?
No, there is no where clause.
Yeah, there's a where clause also. Correct. Yeah.
Where clause, if you have a where clause, it will go to the index.
Yes,
If the
exactly.
index is available.
Yes, there is no where clause, and yeah, I mean, once you get hang of it, like how the queries are running, when you actually try your own, okay, see how my SQL query is performing, then you start understanding the patterns. Okay, this is what you have to look out for, like one of a friend colleague mentioned, like number of rows, in actual number of rows, and in estimate number of rows, which of them is higher? Is it a lot higher? Then what those for. So yeah. So
this is one more thing to add. This sort area, we are seeing this quick sort memory, right? That's
yes.
Also dependent on the work mem. So if you that means your data is your size the work mem large enough to have to perform the sort within the work mem. If your data is extremely large and your work mem is not sufficient, then it will go to the disk. You will not see the quick sort anymore.
Yes, correct. Yeah. another point here is that if you use an index for this query, then what would happen is for every row value in the index, there will be one tuple fetched from the block that carries that row, which means you're hitting those rows as many times as the number of tuples. But if you were to bring all the tables through sequential scan from the disk, then you're loading block by block, which means you are loading many tuples at a time, and then sorting them after fetching the whole table into memory is pretty much efficient than pulling each tuple back and forth to the disk for each tuple.
Thank you so much.
Does it depend upon any hardware?
It does. I mean, there are few because they depend on time of the day time of the day function. So time of the day functions are dependent upon the hardware. So yeah, there will be some changes. So, but now the hardwares are extremely powerful, so you don't see that many changes. So.
There are questions, thoughts. For one SQL, there is multiple plans, right? Sometimes you get a good plan back. Can we fix that good plan? Particular way, any way we can fix it. So whenever I run the SQL, we used to get the same good plan. Is there any way?
Yeah, it is possible. It is there. Yeah. In Postgres, you can use like Oracle and
Yes.
Oracle. You have the plan.
Yes, plan.
That plan you have to do it. There is one extension available. You take that extension and you use that one. But every time, let's say the 10% of data will grow, your plan will also change.
Yes.
So once you implemented it, make sure that the same plan is viable also. Otherwise, once the data will grow, your plan will become ineffective.
Yes.
Yeah, but the community, Postgres community, strictly advocates against fixing a plan for a query because that's a very wrong way of
Because we need to understand why a bad plan is selected and address that problem.
Yeah.
Awesome. Thank you so much, Zubair.
Thank you so much for listening.